So in this video we'll look at remainder theorem for polynomials, but before that let's just look at what is a remainder. So let's take a number. Let's say I divide something like 31 by 6, right? So let's say 5 times, I say 30, and essentially I say what's left is a remainder, right? So what do we know about a remainder here? Well, the remainder can be 0. When I'm dividing a number by 6, the remainder can be 0. It can go all the way up to 5, right? But the remainder can't be 6, because the remainder is 6. Then again I'll get, in this case for example, 36. Okay. What is more important is that you can actually write this result. No, you can write the result. Result means the original number. I can write 31 as 6 times 5, right, plus 1. Okay, so I can actually write the original number, right? So the original number I can write in terms of what I was dividing by, right? The divisor times the quotient plus remainder. Okay, so this is fundamentally the concept we will be using in order to understand the remainder theorem. Now the remainder theorem, you have to understand, is not general. It is simply dividing something by a single by a linear polynomial. It says linear polynomial, it means it just has an x, that's it. Okay. Now, how is that critical? So if I take, let's say, some p of x, and I'm going to take a specific example and we'll work through this. So let's say I have x squared plus 3x plus 5, okay? And I want to see when I divide it by, let's say, x plus 2. Now remember here, the root of this is negative 2, okay? So I want to divide it by x plus 2. So I'm going to call this q of x, okay? So when I divide p of x by q of x, there are many ways to do it, and one of the ways we've been looking at is if I write it as a table, right? So if I write it as a table, this is square, so I just need one more, okay? So to get x square, I need x square here, so I'll have x, and then that will give me 2x here. To get 3x, I already have 2x, I just need an x here, so I need a 1, and I'll only get a 2. So that means that my remainder is going to be 3. Okay, I could have used the colors better, but essentially what this is, what this means is that if I was, okay, I'll write remainder at least as 3. So if I going back to this, right, I can express my original x squared plus 3x plus 5 as a product of x plus 2 with x plus 1, which is my quotient, and I will have a remainder of 3. Okay. So pictorically, I already drawn it as table, but pictorically what this means is if I had x, right, and I had, let's say, 2, 1, 2, and I could have got x here, and I would have got x plus 1. And this table, when, or the shape, when I complete it, right, it becomes x. Would still have, well, 3 blocks left from the original which I wanted, which was x squared plus x, which is 3x, and I wanted 5, but I'd only get 2. Okay. So this is important because when I say I am putting this length is x and this length is 2, when I put x equal to negative 2, it means the height of this goes to 0. So this whole product, this term will go to 0, leaving only these. And that's what the remainder theorem shows. So that if I put x equal to -2, so this was my px. So here I know that the root is x is equal to -2. That's why I wrote it as x minus a. So a is the root. Anyway, so if I put p of -2, right? And you can work this also out. But essentially this one is going to go to 0. So if this is 0, 0 multiplied by anything doesn't really matter. So this is irrelevant. And I am going to get 3. So p of -2 is going to be the remainder, which is 3. And we can of course work it out, which will obviously give the same result. So -2 square, that's 4. 2 times 3, -6, plus 5. Okay, which gives me the same 3. So again, what is the remainder theorem? The remainder theorem is that when I have a polynomial which has a degree more than 1, p of x, and I divide it by a linear, which means only with the power of 1, so something like x plus 2, x minus 3 and so on, then the remainder I am going to get, which is basically this, is as good as substituting that the 0 or the 0 into the polynomial where you had x. So because this whole term will go to 0 and what will be left will be the remainder. That's it. This is the fundamental principle of the remainder theorem.